what the instantaneous slope is for certain functions. And so I know on your notes that I gave you, I have mentioned it says we're going to now start to prove the shortcut rules, and I kind of gave you a list of the rules that we're going to focus on in our class. So that's a comprehensive list of the rules that you're going to need to know. I will give you flashcards for those. I have flashcards made. I have to go have them run off at the bookstore. So tonight what I wanted to do is just introduce how to prove the formulas, and then after we understand the definition and what the formal definition means and how we can use it to prove the rules, in the long run we're going to have this set of rules, shortcut rules, and we'll just use them. But if you're asked to prove something, you want to do an activity like the one I'm going to get started with, okay? I think I'll start with x squared. And so I'm going to work with the function x squared. So notice up here, I mentioned x squared, x cubed, really any power. So we're going to work with x squared. So here's the graph of x squared. By the way, if I tried to draw a graph of the derivative, notice the slope is initially negative. And then right here at the vertex, the slope is 0. And then the slope is positive. So a graph of the derivative would look something like that. What I just drew kind of with the wide part of the chalk is kind of showing what the derivative looks like. Oh, and by the way, I think I did mention this the other day. I remember talking about it. Notation that means the derivative is to write this little straight bar. It's kind of like an apostrophe, but it doesn't have the curl to it like an apostrophe. It's called a prime. So you'll hear people say f prime, and it means the derivative. Okay, so I drew f prime. This was my function. Okay, so if we're finding the instantaneous slope at some point, so let's say here's my point A, we know that to calculate a slope, we really need 2 points. But the instantaneous slope is supposed to only involve the 1 point. So how can we get around that? Well, we can start by saying, well, what if I pick 2 points that are pretty close together? And I found the slope between them. That would be a pretty good estimate. But then your buddy might say, well, I can find a point that's even closer. And so if I then find the slope between those 2 points, that's an even better estimate. And then a third person might say, well, wait a minute, I found this point, it's even closer. And so the line between those 2 points would be an even better estimate. And so on and so on and so on. If you take that idea, we're finding slope, and what is slope? It's the difference between y values over the difference between x values. So A is the special, specific point I'm interested in. F of A is its y value. X is representing the x coordinate of these points that we were picking, getting closer and closer. F of x are the y's that go with those points. If I take the limit as the x's that I'm picking get closer and closer and closer to the special A that I'm interested in, this is one of the versions of the formal definition of the derivative at x equals A. There's another version that says the exact same thing, and after we finish one proof, I'll point it out. It's actually kind of more, you're going to find it in more books, but I like this version because it looks more directly like slope. And if you talk about the idea of a derivative, you talk about picking points, getting closer and closer together, and if you put those words into symbols, it looks more like this. Okay, so that's why I like going with this version of the formal definition. So if you're asked for a formal definition proof, it means you're being asked to set up this limit, and you're supposed to work through this limit. Okay, so for the function x squared, f of x is x squared, and f of a is a squared. And I want to work out this limit. Generally, you try to plug your value in, but if I try to plug a in, I'm going to get 0 in the numerator and 0 in the denominator, and I'll be stuck. So when you get 0 over 0, it means you need to do some algebra. And in this case, I'm going to factor the numerator, and I'm going to factor the denominator. Well, the denominator is already factored. And notice this will cancel that, and I end up with the limit as x goes to 0, and it should be a. And now I can evaluate this. I can go ahead and plug the a in. So I get a plus a, which is 2a. So what I just proved is a formula that tells me the instantaneous slope at any point on x squared. And notice 2a, a is any x value. Notice that's a line, 2x would be a line, and when I drew the picture of the derivative, I drew a line. Okay, so for example, f prime at 4 is 8. The slope on x squared at 4 is 8. I plug the 4 in here in this formula. F prime at -7 would be -14. The slope at -7 would be -14. F prime at 0 is 0. F prime at 5 is 10. Okay, so I just proved that if your function is x squared, the slope is 2 times x.